Hey everyone, welcome back to another episode of Unscripted Coding. Today we are not going to be doing anything too demanding. It's a heat wave where I'm at. Energy is quite sapped, and so I do have a fan running in the back and the windows open. So forgive me if there are bits of background noise. But what I'm trying to say is I wanted to do something that's relatively simple that we can do in one kind of thought. And so let's look at LeetCode again. That was really fun to try and solve algorithms, but we haven't successfully solved a hard one yet, not with all of the edge cases and everything. So that's a sore spot that hopefully we can deal with today. You know what? Let's see if there's something hard on the daily challenge. Not sure. Yeah, you know what? I'll just stick with what we know. Hard difficulty, and let's go page 3. Oh, it's sort by acceptance, so maybe a little higher than that. Let's pick something down here. Let's look at this one. Couples holding hands. That sounds wholesome. All right. First things first, I will go with Python, and I will open up code.codescope. Okay, so this is problem number 765, couples holding hands. There are n couples sitting in 2 n seats arranged in a row and want to hold hands. So n couples, that is 2 people per couple. That's why you need 2 n seats. The people and seats are represented by an integer array row, where row I is the ID of the person sitting in the ith seat. The couples are numbered in order, the first couple being 0, 1, the second couple being 2, 3, and so on, with the last couple being 2n minus 2, 2n minus 1. Return the number of minimum swaps so that every couple is sitting side by side. A swap consists of choosing any 2 people. They then stand up and switch seats. So, all right, I'm not quite sure what this means entirely. So integer array, row I, you have a row, and presumably you would have 1, 2, 3, 4, 5, 6, which are the IDs of all the people sitting there. The couples are numbered in order, first couple being 0, 1. So always 0, 1, 2, 3, 4, 5, and so on. Okay, in my mind, I'm thinking there are going to be interesting edge cases. My first thought is we would have a row, and then we would check each pair. So it would be 0, 0, 1, indices 0, 1, so the first 2 seeds, check those 2. 3, 4, no, 2, 3, 4, 5, and so on, checking each set of 2 seats to make sure that they are side by side. They are consecutive integers. That would make sure they're a couple. Now, I'm saying this thinking it doesn't matter if seat number 2 and 3 are consecutive, because you would leave an odd number before and after, and at a certain point by the end of it, you would be breaking rank. So you need to compare every 2 seats together and make sure they're consecutive. And the idea is you want the minimum number of swaps. This is not the minimum runtime. This is the fewest number of switches. So we can go through a couple loops to figure out what the order is before we make the actual swaps. Wow. Okay. This is a difficult one. All right. So we have row 0, 1, 2. Is there a test case? Okay. 0, 2, 1, 3. Oh, what is this output? Oh, the output is just the number of swaps required. It's not the actual swaps made. Okay. Let's create the class, and then we run it. Min swaps couples. No, let's go output equals that. And we were given a row. So we will put the row here, and we will print output. See if we get 1. Perfect. Okay, so we can start doing the logic here. Okay, I am gonna go with this every 2 step. Oh, the other question I have is it possible for them to flip backwards? So let's say 0 and 1. Person 0, person 1. Can they sit beside each other so that it's 0 and 1 or 1, 0? So the couple can sit in either kind of orients. And I think they can. 0 and 1. 3 and 2, 0 and 1. So example 2 over here, 3 and 2, 0 swaps are required because normally it would be 2, 3, but they're 3, 2. And of course you can count up as well, 0, 1. So that is a helpful test case. Okay. Okay, let's see. Num people equals like row. I can range num people. I 0, 1, 2, 3. Oh, I am drawing a blank here. So how do I? Oh, this is bad. I'm just drawing a blank here. How do I search every iterate through every second 1? So 1 plus 1, 2 plus 1 times 2. Which one sec? Pen and paper, always helpful. Let's see. So I have 0, 1, 2, 3, 4, 5. I want 0 and 1, 2 and 3, 4 and 5. Okay. So print I is 2 and print I times 2 minus 1. Oh, I should be lost. Zero, 1, 2, 3, perfect. So that's how we're going to get our pairs. We're going to go every second number and the one next to it. What we want to do is find the index first number equals. No, let's go first index. Second index equals this one. But first person equals first. I think they called it ID, so let's keep it that way. And we use the indexing. Second ID equals 12. You know what? This is long. Let's go index 1, index 2, ID 1, 2. Shorter and less type this way. Index 1, index 2, and we will if ID 1 minus 2 does not equal 1, 1, and no. Okay, let's run that. 0, 2, 1, 3. Okay, so neither of these are good, but if we went like this, they should both say yes or no printing at all. And that's not good. What's happening here? Why is ID 1 minus ID 2 negative 2? Okay, let's print two numbers, ID 1, 2. We have 0, 2, and 1. Oh, no wonder. I should be changing it here. There we go. Okay, so in this case, I didn't want either of them to print 0, 1, and 2, 3. Basically, those couples are sitting beside each other already. If we subtract their ID and they're only 1 apart, and I think there's a better way of doing this, just an absolute value. ID 1 minus 2, that's not 1. Not a couple. Oops. And let's go back to the other test case. Okay, so these two are not a couple. It's good. So we ignore that. But if they're not a couple, we should register it. List of not, no, let's call it not couples list equals. And for each one, we're gonna log it. Not couples list dot append 1 ID 2. And not couples. Oh, that's not. Print not. And let's not have to switch this over. Okay, so I'm just trying to think now. This is not a difficult problem to solve, possibly. Let's say you have 3 sets of people that don't match, 3 sets of couples. What is the minimum number of swaps? Oh, I see. So my thought here was there's 2 sets of couples. It is always going to be 1 swap. It does not matter who you swap. So in this 0, 2, 1, 3, doesn't matter if you swap 2 for 1 or 2 for 3, or 0 for 1 and 0 for 3. No matter what happens, you have 2 couples. As soon as 2 people move over, they'll both be staying in the right place. Is that true if we had 3 people? Or, and let's go 5 for here. 5, 0, oh, okay. 1, 2. So you can do this in 2 swaps at the least. You can't do this in 1 swap because 1 swap will only affect 2. So at the very minimum, you need to do 2 swaps. 4 moves over to here, and then you want to swap 0 and 1. Is there a situation where we must do 3 swaps when there's 3? Let's think through that. No. There will never be a case where you have to do 3 swaps in 3. But once you hit four numbers, it is possible. So let's go with this one. It is possible that you need to do 3 swaps or 2 swaps. So for example, this one, you would, so hypothetically, let's say they are just 2 sets of 2 couples that have been mixed up. You would do a swap between these 2 and a swap between these 2. That is 2 swaps. But if you have elements from each one of this one, then you'd have to swap once, twice, 3 times. So it's possible to have 3 swaps. And so I can't just say, there's 4 couples, so I know you can do 2 swaps, or 3 swaps, or whatever fixed number. You do have to calculate this one, unfortunately. So I think I would break this up to a n swaps. Count swaps. And then we will have the not couples list. Okay. Oh, this is the perfect example, actually. There is a minimum swap, so 6 and 0 switches, you would have 2 sets complete. 7 and 4 switch, you have 2 sets complete, so you have 2 swaps. We can do this very inefficiently by moving to... Okay, so I'm just thinking through the very naive implementation, which is for each one of these pairs, I'm going to go, okay, we have this one, 5, 0. This is obviously not a couple. I'm just going to look at the first number, see the next, basically find who he has to partner with, which is 6. Oh, no. No, I'm doing this wrong. The couples are always fixed. It's 0, 1, 2, 3, 4, 5. So I can't just say 5 partners with 6. 5 only has 1 partner, which is 4. So I gotta rethink this one right here. So for each set, I count the first 2, I get the indices of the 2, and the IDs. Subtracting each other and equaling 1 is not good enough. 0, 1, 1, 2, 2, 3, 4, 5. Okay. So let's think of 0. Partner has to be 1. 2. Okay, so I think the easiest way to think of this is every even number plus 1, exactly like this. So if I get an ID, 3, every odd number, okay, ID 1 equals So I'm thinking to make sure 0 and 1 always pair up, and 2 and 3, every even number is the lower side of that pair. 2, 3, 4, 5, the even number is a lower one. So I just gotta find the even number of the couple and then add 1 to get the odd number of the couple. Odd ID. Okay, so I gotta find if. I gotta find out. I can do multiple checks. I think that's the fastest way to do it. So the first check is if ID1 plus ID2. If I do a modulo of it, 2 equals does not equal 0. So you add an odd number and an even number, modulo has to be 1. If you add 2 even numbers, if you add 2 odd numbers, you'll get modulo 0. So as soon as you get modulo 0, you know that they are not a couple. Okay. Else if I think that's if. Now, if that test fails, we know there's one even number and one odd number. So I'm going to say odd ID equals if ID1 modulo 2 equals 0, odd ID equals odd. Does that make sense? So the first check is if we add the two numbers together, they're even, then it's either 2 odd numbers or 2 even numbers. They can't be a couple because they're not consecutive numbers. Now, else, and then we try and figure out which one is the odd and which one is the even number. And then we say odd ID minus even ID equals 1 if odd ID is not 1, then not couples list and list. So now we subtract the odd number from the even number, and if it doesn't equal 1, then they're not consecutive numbers, and they're not the right consecutive number. So it's possible, let's say 5 minus 4 to have 1. That is a valid couple. But if we go 3 minus 4, that is a wrong couple, even though they are consecutive numbers. And so we have not couples list, append ID1 and ID2. This equals. Okay, The second one. So we found the right couples. Now, I do want to put in a test case. Let's easy case, 2 couples. And let's make it challenging. 1, 2. Zero. 2 bad couples. First one is and now we recognize both of them as wrong couples. Count swaps. Great. Okay, so I am going to do this in the most naive way possible. 4. Neighbors and not couple list. 1 plus 0, 2 neighbors. Okay, I 1, 2 equals 0. Okay, so where we're at now is we're going to pick out the first one. It really doesn't matter. We're going through the list, picking out the first one, and I'm going to do it the most naive way possible. I'm going to find out who it should be partnered with. So we know 5 should go with 4 over here. And we're going to go down the list and find 4 and make that swap. Okay, you know what? I will index 1. And in this case, because it's 5, we're going to find out whether it's even or odd. If it's even, we add 1 to it. 2 equals 1 plus 1. And if it's odd, we subtract 1 from it. Equals 1 minus 1. Now, we have the 2 pieces. We have the 2 IDs. We know ID 1 is existing already. ID 2 is what we're looking for. So we are going to start again for X and not couples list. as the first one for y and couples with x. And that's majorly annoying. So we've made the swap, so you can see 5061, and then now we have 546732. I would have thought we can do this in two shots here, and you can see this is why. Now I know why we're not doing it the naive way. If I did this 5601, it would be one swap here and one swap here. 3, 4, and 2, 3, and oh, maybe not. Oh, maybe that is the right way. I'm thinking 0, 1, and 5, 6 were pairs, but 5, 6 are not pairs. So always take a look at what you're thinking in your mind. But here you can see the first thing we did was swap 0 with 4. So it became 5, 4, 0, 2. And then we swapped 7. So 6, 7, 3, 1. And then we swapped 2. So 2 and wherever that was. And then I'm not sure why that last swap would be necessary. I would have thought these two were in. Oh. So if you take a look at this 1, 2, and 0, 3, we have 1, 0, 2, 3. Why did it require 2 swaps to do this? And this is why I needed print I2 I. So this one, they swapped 0 first. So 1, 0. Oh, I see. So I made the swap 1, 0, and this one, we are going through every single pair. We didn't do a secondary check. We didn't go, okay, now that the swap is done, we move on to a second one. We should first check if it is a, what do you call it? It's an actual couple first. So we need to do a check here. Want a my naming conventions are absolutely terrible, but we need to figure this out. Okay, let's. Yeah. So I'm gonna abstract this out. Now we will track these colors. If they are, then wait. Okay, that looks more like it. Skip that. Skip this print. There should be 3, there should be 1, there should be 0. And let's submit this and see how we do. So we passed 38 out of 56 test cases. Okay, let's see what is that. Okay, so the problem was the break was breaking out of this entire for loop. That is a simple semantic mistake. Let's hope we got this. Woohoo! We did it! 49 minutes. And blistering heat. Less than 8.1. Yeah, these are pretty horrible runtime. So we can definitely do it a lot faster, but when I was reading the code or when I was reading the problem, it just didn't matter what it was. We didn't need to think about this too systematically. We can definitely try and make this run faster. We are probably checking over the same things over and over, but let's just leave it at that. We did it. I was kind of horrified that we didn't get all 58 cases right off the bat, but it was just a simple error over here. So I hope you guys had fun. I may be odd one. I may be the odd one, but these LeetCode problems are really, really interesting and are really fun. part of what I'm finding about this platform, which is nice, is you can go and see your old submissions again. So later on, you can see what you wrote. So I may revisit this in 3 months, can't remember a thing I did, and think about something more efficient or more clever. But I have no problem with trying to do this in the most systematic, naive way possible. Now, if you enjoyed this, please do subscribe. Please do comment. If you didn't, we will be putting up other types of videos, not just solving these algorithm ones. So thanks for watching.